Okay, so next question here. As a projectile rises towards the peak of the trajectory, the horizontal velocity will decrease. As it falls from the peak, its trajectory, its horizontal velocity will increase. What? Are you kidding me? No, that's completely false. The horizontal velocity is going to remain constant at all times. Next one. A projectile is a free-falling object. True. A projectile must be moving in the downward direction. False. What about when it goes up? Doesn't have to. A projectile has an accelerating in the downward direction. True. The horizontal velocity of a projectile changes by 9.8 meters per second. The horizontal velocity? No, false. The acceleration does. Next one. A projectile with a horizontal component of motion will have a constant horizontal velocity. True. A horizontal velocity of a projectile is 0 meters per second at the peak of its trajectory. Horizontally? False. The horizontal velocity of a projectile is unaffected by the vertical velocity. These two components of motion are independent of each other. True. Let's keep going. As a 55 meter rope is connected to the top of a building, it is attached to the ground 40 meters from the building. What is the angle the rope makes with the ground? Do not give the degree symbol. All right. Here's the building. Here's the ground. All right. Got a rope that's attached to that building. And how long is that rope? 55 meters. And it is attached 40 meters from the building. So from here to here is 40 meters. At what angle to the ground, look at this right here, is this a rope attached? Well, step number 1, after you do your drawing, you should come over here, do your right angle and draw your arrow, find your hypotenuse, your adjacent, and your opposite leg. We are looking for the theta. What do I have? I have the hypotenuse leg and I have the adjacent leg. So I'm going to come over here and I'm going to write so, ka, toa. I have the H in the A. The H in the A is the cosine. So the cosine of the theta equals A over H. Or the cosine of the theta equals 40 over 55. Okay, grab our calculator. What is step 1 here? Make sure your calculator is in degrees. 40 divided by 55 came out to cosine of theta 0.7273. Okay, now that's not my answer. Like square and square root, you have to do the opposite. So the opposite of the cosine is the inverse of the cosine. That is going to be your second key, cosine, 0.7273, close parentheses, equals, the theta equals 43.34 degrees. Okay. Let's keep going. Number 8. Number 8 says that a projectile has an initial horizontal velocity of 5 meters and initial vertical velocity of 3 meters per second upwards. At what angle is a projectile fired? Okay. And here's my ground. There's a projectile that was fired, and it says horizontally 5 meters per second. So horizontally, this would be 5, and vertically 3. What is the angle the projectile was fired? That's what I'm looking for right there. So I see that I have 2 legs. I'm going to decide what are these legs. This leg is my hypotenuse, adjacent, and opposite. So they were given the opposite and they were giving us the adjacent. Come over here and write SOHCAHTOA. A and the O is the tan. So the tan of the theta equals O over A. Or the tan of the theta equals 3 divided by 5. Again, make sure you are in degrees. 3 divided by 5 comes out to 0.6. Not my answer. I need to do the inverse of the tan, which is the opposite. So second key, tan, 0.6, close parentheses, 30.96 degrees. That's your correct answer. Turn the page. Let's keep going. Says here, though, from a horizontal distance of 60 meters, the angle of elevation to the top of a flagpole is 22 degrees. The horizontal distance is 60 meters. Horizontal, the angle of elevation to the top of the flagpole is 22 degrees. Make sure you use the correct SI unit. I have 1 leg. I'm looking for how tall is this flagpole. So this is the leg that I have, and this is the leg that I'm looking for. My next step for me would be to come over here and find out, this is my right angle, so draw an arrow. My hypotenuse, adjacent, opposite. Okay, so SOHCAHTOA. My A and my O is going to be my tan. So the tan of the theta equals O over A. Or the tan of the theta equals O over 60. And I have that tan, which is 22 degrees. I should have wrote that in. Okay, we're going to use our algebra and we're going to isolate for the O leg. So multiply this side by 60. Multiply this side by 60. The O leg, which is the opposite or the height of the flagpole. Come over here. The tan of 22 degrees equals, and we're going to multiply that by 60, 24.24 meters. Okay, let's keep going. The path followed by a projectile is called the path that it takes is the trajectory. What is the shape of that path? The parabola shape. The next one here, you've got 2 vector arrows. Type in the magnitude with the correct SI unit and direction. These 2 vector arrows are in opposite direction. If they're opposite, we're going to subtract. 75 take away 70 equals 5. So my answer is going to be 5 newtons. That's the SI unit behind it. To the, which one is a larger value? This one, to the right. So if you wrote the word right, that's correct. Or if you wrote 5 newtons to, I think somebody wrote east, that way, that's also correct. That would have worked. I gave you points as well. You got your points. Next one, number 12. A ball is tossed vertically upward, rises, reaches the highest point, and then falls back down to the starting point. During this time of acceleration, the ball is all. During this time of the acceleration of the ball is always directed downward. During this time, the acceleration of the ball is always directed downward. Next one, a person flying a kite has released 122 meters of string. The string makes an angle of 32 degrees with the ground. Okay. So there's a string that's 122 meters. Here's the ground, and it makes an angle of 32 degrees. How high is this kite up in the air? All right, well, I look at it and I see that I've got this leg and this is my unknown leg. They did give me the theta, so I'm going to draw a right angle, 90 degrees, draw an arrow from it. This is my hypotenuse, my adjacent, my opposite. I'm going to write over here, SOHCAHTOA. Now I'm going to go ahead and decide what equation. I'm going to use the equation with the H and the O, which is my sine. The sine of the theta equals O over H. Or the sine of 32 degrees equals O, which is the opposite, over 122. Let's use our algebra and let's get rid of this 122 by multiplying it. That cancels. Multiply by 122. The sine of 32 degrees times 122 equals, how tall up in the air is this? It is 64.65 meters up in the air. Okay, oops, sorry. So again, I will post this video as well as take pictures for us. And a couple more questions and we are done here. First one here says, if a projectile's initial velocity is completely in the horizontal direction, what does this mean for the initial velocity in the vertical direction? If a projectile's initial velocity completely is horizontal direction, projectile. Let's go back. Let's draw a little cliff. I've got this. And there's a velocity here. Let's pretend it's 100. It's going to form a parabola shape. What is going on with the initial velocity? What's the initial velocity? What's the VI right here, vertically? 0 in the Y component. Correct? It is equal to 0. And then the path of the shape formed from the projectile is a curve. It is straight. This sentence came straight out of our notes, called a parabola. Okay, so there goes our quiz that we just took. I videoed all the answers. I'm going to take pictures for it. We can go over it. Please have your questions ready for me in class. Alrighty. Talk to you later. Thank you.